Josh Hand.
Alright, we were with the, built our ATAC, the automated t-shirt air cannon. Our basic problem is there's really no existing t-shirt cannons that can really hit the top level of the bleachers. So when they come out in sporting events and they try to get the crowd amped up, like they're going to toss away a free t-shirt, it's always the people that are closest that get excited, because when you're up in the top, it's never coming to me, why should I get excited? So we're trying to fill that gap, and also we're going for precision on it. We've designed a ballistic computer, so you could actually tell it what section you would want to drop the t-shirt in, and you have a fair amount of accuracy of knowing that it is going into that section, as opposed to just someone just kind of aiming one and going, okay, that should be there. The objective that we set for ourselves was we wanted to hit a target distance of 100 feet. We wanted to be within a 4-foot diameter circle, and we wanted 50% reliability of landing inside the circle. Our basic design is a basic t-shirt cannon. We didn't do anything real special on it. The nifty thing that we have here is a face sealing piston valve. So,
what state of the art?
The current one?
What's the current range and
There
radius?
are a lot of options that can shoot 200-300 feet. If you look at the t-shirt cannon things, there's a lot of like specialties. So you have your general one that you kind of hand point, the most common one. Those can get to 200-300 feet in distance, but it's point shoot. Then they have other specialty ones that can get maybe farther range, or they're stationary, or they load a different way, or the kind of Gatling style. But we didn't see anything that's like precision, like targeting. So we don't really have any data about state.
Are there companies that make this stuff? Really? I've seen these things, but I never thought.
And they sell for comparable for like even a handheld that's comparable distance to ours. That runs about $1,500. So and that's without any precision or control on it.
Is there a safety aspect to it too, like the rate at which they're being shot out?
Or like the speed?
Yeah.
Or, we haven't run into any problems with that yet, so we don't know what the top end. The speeds that we've worked with are fine as long as you're not standing, at the barrel. By the time you get to the point where you catch it, it's the speeds are it's coming down at like 34 miles an hour, which is comes with like a hard football catch or
34 miles coming out, or when you're
when you catch it. Coming out, it's closer to I believe like 180 or 70. Yeah, so but you wouldn't stand there with another type of cannon either. So you'd always have to make sure you got the clearance on shooting. But as far as catching, it's safe.
So I hear what you're saying is precision is what you're pursuing.
Yes.
Why is that important? So if I own a team or a facility, and I wanted something like this, why would precision be so important?
Precision on it, you could tie it into like the jumbotrons, like when they want, like okay, we're gonna randomly select, someone to get a t-shirt, and it could go through, okay, section 108, and you can have it click down to row this, seat this, and you can actually launch the t-shirt, and it is actually gonna go within a few seats of where that's supposed to be at on there. And it's more like an advertisement thing on there. You go to a game that if you're using our system that is precision, there's nothing else like that. It's comparable like when when they first got their Gatling gun one, it was like, oh, did you see the new Gatling gun t-shirt that they have?
So the other thing, you can set up scenarios where you have fans competing. Like, hey, you really want to get some shirts, show us some noise, and then they can compete. You can target the specific crowds that are doing that. Also, the base design in general, we see some other potential applications like if you're running like ROTC or like mortar simulators. That's a use. We could maybe put like a paint bomb in there and run drills with that with the precision, or you can maybe set up some kind of raffle thing where you have targets, certain points or something. People can buy a raffle ticket for a fundraiser and try to hit the
So
point.
you said 12 feet, is that what I heard?
12-foot diameter. Yeah.
So that covers a lot of seats.
Yeah.
So you can only do a section.
Yeah, it would be a sub part of a section. We would have seat precision. Yeah.
So, and then our valve here, it fills from the back side, so the valve will actually slide up, press up against our barrel, seal it, and there is, we have a check valve in here, so then the air can flow into our storage tank. And then when it comes time to fire, we have a ball valve on the back that can actually dump the pressure here. So then, because of the difference in pressure, the valve moves back and there's no restriction in there. And using this option, we have the ability to fire with really low pressures and achieve very high distances on there. The pressure that we're going to be shooting today is only 15 psi, and you're going to see how far that takes it.
Is it a dial or is it something?
Yeah,
dial
yeah.
that you-
We have a gauge on the like we hear in a regulator.
We have a
on the
gauge
back.
coming off the end of the reserve chamber that tells us what the pressure inside of it is.
So they have to dial in the pressure, or they can dial in a distance?
We use in the computer here. We have an algorithm GUI here, so you enter in. This is assuming you have your coordinates pre-known, so you can either map a GPS or in this case it's an XYZ coordinate. So you enter in your coordinates.
So you have to know where section 108 in terms of.
Yeah, in this version. And then you so you can, if you have a stadium, you can pre-map it and you just have targets.
So it'd be rolled out to a specific spot, and then it would take over the targeting.
Yeah, and it wouldn't necessarily need to stay in the same spot you're targeting. You would just need to know where all your targets are, and then it'll adjust to where it is.
Okay, got it.
So
But that's not built into this application yet. So what?
No.
not that part, no. So you would enter your coordinates, you calculate, it tells you what the shot distance is, and the rotation angle you need azimuth. Then it generates a table here of available elevation angles and pressures that should get you to within the distance you want. And it's sorted by final velocity, so you can minimize impact velocity to keep it safer, or by error from the target distance. So you can kind of, right now you can either pick it, look at it manually, decide which one you want to do. Now that'll tell you what pressure and angles you need. You can input it and set it to that. So the catch today is, when we moved it in here yesterday, our controllers don't want to work correctly. So the targeting to move it, actually angles are not working right now. What we're going to do is demonstrate a shot from the static position, and then we can show you how the motors work by activating them individually and show how they work in position. But right now it doesn't want to work altogether.
Have you done a market investigation? Have you done it to any of the potential customers? And ask them what they think about it?
Not yet. We just heard some hearsay, and people around here that hear about it and are kind of excited by it. If they go to what's the local? Yeah, and somebody we heard from Molly. Somebody was like, "Oh, I was at the Wranglers game. All they did was throw shirts, and they know about your project, and it sounds exciting." So we haven't been able to do that yet because, as it turned out, everything on this took a lot longer than we thought, and especially with only 2 people. We had a lot of problems with the getting that valve seal right and the fire right. These.
Did you machine the whole thing yourself, build the whole thing yourself, or did you buy some of these?
We bought like the PVC components. We bought that off the shelf. Basically anything that's not black, we bought off the shelf. Everything else we had to make. All our metal mounts, I turned those out in the machine shop. And then the modifications to the PVC to assemble the canopy, we did that in the machine shop.
Where'd you come up with it?
The concept, we came up with it back in 497. We were thinking of a project, and we're like, we like the t-shirt cannons. It was just kind of wondering, wouldn't it be cool if we had a t-shirt cannon that could do this? And then we kind of looked into like, that actually sounds like a pretty good idea, and it would kind of be a fun project to work on for the full year. And it turned out to be a challenging and useful experience, and we learned a lot.
You got plans to commercialize it?
We're looking into that. With just having the 2 people, we were focused really hard on getting it built and getting a functional version of it.
What was your biggest learning with this whole thing?
Biggest learning on it is one, get what you pay for a lot of the parts, and having to design.
That's true for anything.
Yeah, having to design around a lot of shortcomings on parts that would fit our budget.
Also, multidisciplinary teams are good because when it came time to do the more in-depth coding and programming, I could do like this surface level stuff. But when I ran into some trouble with getting like MATLAB to talk to the Arduino and stuff, I got to a stopping point when it started getting into really depth technical jargon about programming stuff that we haven't seen yet.
And both of you are what, mechanical?
We're both mechanical.
Okay.
Yeah.
And everything's, you modeled this in MATLAB? Is that what you did?
Yeah, this is a MATLAB GUI builder, and then this codes back to subfunctions. That what that does at the subfunctions is it takes every available angle and pressure combination and simulates a flight path, and then filters out for when the projectile would pass through the desired zone, and then that's what it returns to you in the available results.
Did you find out that designing the projectiles was as important as designing the?
Yeah, and we still haven't quite mastered that yet. We got this press machine So you pop this, you have a drilled out spark portion here. You put this together and put it into a press. That would be like kind of what you start with.
Yeah. This is like what's traditionally thrown out of a t-shirt cannon. Resembles a burrito, and it flies like a burrito on there. So with our press, after we press them, they actually come out like this, and they retain the shape very well. And then we shrink wrap them.
Just to make sure we can hold it consistently.
Yeah, and then actually if you flip that one on the back side, we actually have an ad placement on there, so you can, you know, venues, we can actually put whatever logo that they would want on the back.
So then the problem we found out with our testing, our initial round of testing, our values were all over the place. We had not much stability. So this is the first round of shots, and this is our shot distance straight up, and this is our offset side to side. So we were kind of all over the place. So then we tried this design. We didn't have time to rifle the barrel because it was kind of toward the end. So we tried to go at it this way by adding some kind of fin ridges in there that would hopefully impart a little spin coming out. Unfortunately, that didn't work right. It didn't give us much spin, and all it did was increase our exit pressures because it did. Which one are you putting in there?
I'm putting the right one in there.
Okay. So all it did was actually increase our shot power, and I think it's because these created a tighter seal inside the barrel. So now we're getting more of the energy transfer to it. These are little foam cores, and what actually happens, so we would press the base shirt, wrap it, then put these fins and have another wrap. So that extra wrap gives us a little more protection in the barrel, and when you only have it like that, when it fires out, actually it rubs so much on here that that outer wrap comes off and the fins drop, and then you just have the base thing, which is great if we're actually going to do it that way. It was horrible for testing because you get one burn per, so we had to reinforce it with like packing tape just to get multiple shots. And this is our results for with the fins.
Any other applications for this that you guys came up with?
Yeah, I'm thinking the most common one maybe would be like it's like a military training tool. You put like paint bombs in there, simulate mortar fire for like ROTC or something like that. That would be the most obvious one. Like I said, raffle, anything to generate excitement, fundraising, stuff like that. You want to do it? Yeah. You want to smile a little bit. This angle is about 28 degrees.
And what do you expect? How far do you expect this to go?
This one should hit near the top of that curve. Is that a reinforced one you grabbed, Jay?
We'll find out. And firing.
So we got the distance and stuff, but we still would need to investigate more with the shape to get stability, to get that spin. If we had more time, we
But I mean,
would.
from an application standpoint, a little bit of unpredictability is a good thing. That you know, you're not trying to get it to a certain person. You're trying to get it into a certain range. So
Yeah.
part of the excitement of the whole thing is folks fight doing this stuff.
Yeah, the key is, making sure that our range is not 30 feet, but 15.
Right.
So that's what we still have to work on because our data shows right now that it's not highly accurate. The ones that we did get one small data set with the fins without it wrapped in tape, so where we shoot it out and the fins fall off, and that spread actually was promising. It looked like we were getting within what we targeted, but unfortunately there's so much effort and intent required to press these that we couldn't test a lot of that variation.
To get over your limitation here, you seem to focus on making modifications, kind of like your payload and stuff. So, you guys have any ideas of how you can fix your launcher here to tackle the same problem instead of sitting there and pressing and adding fins and all the things?
Yeah, the fins, it was an effort to rifle the thing. We had originally thought of just rifling the barrel, putting the grooves in there. That brings along its own challenges because to use a machine that could rifle this all the way, we don't have one in the shop, and as far as I know, there's not one of those even in Vegas. You have to go to actual gunsmiths that make big barrels. So for our application, we decided to try this because if this didn't work out, we could always change the angle on the rifling, and we wouldn't, have one shot with our barrel. And if it didn't work, then we were stuck with what we had. And then, so
Also, we thought if this would work somehow, this would actually be the most marketable single part of our project because you could fire this for any kind of cannon and get some rifling accuracy.
It's kind of being an emergency response. You can't get the police or they can't sue you.
We're getting better at this thing now.
All right, let's go. Next project.